Okay, so welcome back. Today we're going to look at something you might want to consider if you're looking for a very inexpensive, flexible, portable, variable DC power supply that you might want to use for your personal projects or learning projects or Arduino projects or whatever. And it's something I use all the time and I find it to be very, very useful. Now, if you're looking for a DC power supply, often people will say, well, you need something like this, a commercial power supply with a high current rating and very accurate results. And they'll say you need to have this or else you're just going to blow everything up and you're going to have a terrible time. I find that to be, for the most part, nonsense. For many of us, I think what we need is something that will power our op-amp circuits or our sensor circuits, and we really don't need anything with high current ratings or very low noise, low ripple. I think this option we're going to be discussing is something that's really very useful, and I use it all the time. Now, like you see, I've got two power supplies I use for my bench, a commercial one and then one that I've converted from a computer ATX power supply. And it provides 3, 5, and 12 volts at up to maybe 10 amps. Very useful. Again, people will say you can't use an ATX power supply because it'll blow up all your circuitry, but again, that's pretty much nonsense. Anyway, what we're going to do is look at something, again, it's very inexpensive, and you need to be aware that in the real world, you get what you pay for. And this is inexpensive, and you're going to get not as many features, of course, as you'll get in this commercial power supply. It's not going to be a constant current output, but it is going to give you some basic DC, variable DC, and it will be, at least I've found it to be very, very useful. So we're going to look at two devices. We're going to look at this wall adapter, and we're also going to look at this, which is a buck converter. And I generally use these together to give me a finely tuned variable DC. So the first device is this, and it's a Chinese branded device, and you can see the company is called Belker, and surprisingly it sounds very much like Belkin, an old firm that's been around for many years doing other charging solutions. And so this is Belker, Chinese firm, and you can see it's basically a wall adapter. It goes from 120 to 240 volt AC input, and you can vary down here from 5 volts up to 15 volts DC. Got a lot of different settings. You just adjust this, and it comes with this little adjuster, which you go from 5, 6, 7.5, 12, up to 15. Now, one of the nice things about this is it gives you an output adapter, but it also gives you a bunch of other adapters you can use for different needs. For example, a micro USB, and it's got something I use all the time, which allows you to connect this output to some screw terminals, okay? So I use this all the time so I can wire up to my breadboard or my Arduino or whatever. One of the issues with this is that it's fixed values, right? It's not an adjustable voltage. So what I do is I generally add this, which is a simple buck converter. And this is only like a $2 or $3 device, very inexpensive. You get a pack of 4 for maybe $12. And it's very useful, and it's got a potentiometer here that you can take the input from this wall adapter and use this potentiometer to adjust the output. And it goes all the way up to, it's going to go from 0 to 15 volts, depending on the input from this wall adapter. Okay, so let's take a little bit closer look at these devices and see how much they cost and what their ratings are. So again, this wall adapter is Belker. It's a 45 watt universal, and it's got switch settings for 5 volts, 6 volts, 7.5, 9, 12, and 13.5, and 15, AC to DC. And it's a maximum of 3,000 milliamps or 3 amps. So again, make sure that you're aware that when you're operating this at 3 amps, you may not get a nice clean output. There could be a lot of noise and ripple, so just keep that in mind. In my view, this is good for low current applications where you just want to power a electronic circuit like an op amp or something on your bench. And it's also very good because it's very flexible. You can unplug it from your bench stuff and use it to power other devices. And then if you make your bench test jig into something that's an actual device, you put it in a box and it's ready to go, you can use this to power that whenever you need. So really very nice. Again, the price is about $17. Again, you can get many variations on this. And to be clear, I have no relationship whatsoever with this company. I just think it's a nice device. The other device that we're going to look at is this 4-pack of buck converters. And this one is $13 for 4, which means about $4 a piece. This particular one is by D-Planet. Again, I have no relationship whatsoever with these people. But it's a 5-amp DC to DC adjustable buck converter. And it's got a potentiometer here where you can turn the potentiometer and vary the output voltage. Again, it goes input voltage from 4 to 38 volts. And the output goes from 1.25 to 36. And it says the output current is 0 to 5 amps, 75 watts. The input from this Belker device is only 3 amps. So, presumably you're not going to be using this at 5 amps if you plug it into there. And again, the Belker device, here's some of the details. They say over voltage protection, over current protection. It's up to you if you want to believe any of that. ISO 9000, which is somewhat meaningless. Anyway, here's the specifications like we said. It's got a bunch of adapter PC plugs, works with smartphone, blah, blah, blah. So here's the way I use it. You've got the device 100 to 240 volt AC, 1 amp. Output 5 to 15 volt DC, 3 amp, 45 watt. And I just wire that into this buck converter, which has a 4 to 38 volt DC input and a 1.25 to 36 output with 5 amps. So one other thing I wanted to show is the response of this buck converter to changes in voltage from this wall adapter. So what I've got is I got the wall adapter here hooked up to this terminal strip, going into the buck converter, and I'm measuring the output of the buck converter voltage on my scope. And I've got this now set for about 5 volts output. And I've got 6 volts coming in from the wall adapter. And you can see there's about half a volt plus and minus of switching noise, which is to be expected because it's a wall adapter and a buck converter. Just keep that in mind if you're going to be using this. Now you can imagine what the noise is coming directly out of this wall adapter. It's probably huge. So I'd be very careful about using this directly, but going into the buck converter, you can see it smooths things out a bit. So what I'm going to do is I'm going to adjust this output. I'm starting at 6. I'm going to adjust the output and see what happens to the voltage coming out of the buck converter as I change the input from the wall adapter. So I'm at 6. I'm increasing. You can see there's really no change on the output. Now I'm up to 15 volts going into the buck converter, and there's just no change. So it's doing a nice job of regulating the voltage coming out of the buck converter. Okay, so that's about it. If you like any of these videos, please like and subscribe, hit the bell notifications, and most of all, let others know that we're here so we can get some more viewers. Otherwise, I hope this helps. Take care and have a really good day. Thanks.